The function f is given by f of x equals 5x to the sixth minus 2x cubed minus 3. Which of the following describes the end behavior of f? So the end behavior of f is what the graph does at positive and negative infinity. So we'll just be using the limit to see what the value of f of x is when x goes to negative infinity and positive infinity. So the rules for end behaviors of polynomials is that if the highest degree is even, like 2, 4, 6, 8, the highest degree in the polynomial, if it's even, so in this case it is, we have a 5x to the sixth. This is the largest exponent in the polynomial, and 6 is even. Then the graph of the polynomial will look something like a U-shaped. There may be some ups and downs and smaller local critical points, but the end behavior will be the same regardless. If the highest degree is even, they will either go to positive infinity as the limit of x approaches negative infinity or positive infinity, or they will both approach negative infinity as x goes to negative infinity and positive infinity. Now, the graph of a polynomial whose highest degree is even is concave up when the leading coefficient here is positive. And then it's concave down when the leading coefficient is negative. So here, the coefficient of the highest degree term, the x to the sixth, is positive. So that means we have a concave up function here, which means as x approaches negative infinity, the graph of f of x approaches positive infinity, and it approaches positive infinity when x goes to positive infinity. If it was a negative 5, then we would have a concave down function, and it would approach negative infinity down here. So that's for when the degree is even. When the degree is not even, meaning that the degree is odd, like 3, 5, 7, 9, then the function will be a cubic function. There may be some local critical points and ups and some hills in the middle, but the end behavior is the same. So for a cubic function that has a positive leading coefficient, it'll be shaped something like this. So when we have a positive leading coefficient, as x approaches negative infinity, y approaches negative infinity, and as x approaches positive infinity, y approaches positive infinity. Now, if the leading coefficient is negative, meaning the highest degree term, say this was an x to the seventh, and this was a negative coefficient in front of that, then the graph would be basically flipped across the x-axis. And in this case, as x approaches negative infinity, y will approach positive infinity, and as x approaches positive infinity, y will approach negative infinity. So basically just flip them around. So to find the end behavior, you just look at the degree of the largest exponent, and then you look at the sign of that term. So in this case, we have an even degree, and a positive coefficient. So that means we're going to be concave up, and we're going to have U-shaped end behavior. So in this case, as we approach a negative or positive infinity, f of x approaches positive infinity, which means the correct answer is B.